Alrighty, so let's talk about how to find our mean, our expected value, and our standard deviation of a geometric random variable. So remember, in a geometric random variable, what we are saying is how many times does it take to get the desired outcome? So if x is a geometric random variable, the number of times it takes to get a desired outcome with a probability of success of p on each trial, then its mean expected value is 1 over p. This is how many times do I expect the process to work? How many times do I have to expect how many trials it takes to get one success? That is my expected value. So that's what an expected value of a geometric process is telling me. How many trials do I have to do before I get my first success? And then the standard deviation is the number of trials that we are going to deviate from that number of trials. So like in the last game, the lucky game, we could figure out how the probability that it would take to get that many trials, my expected value. So if we were to look at it for our lucky day test, why don't we do that? So if we are looking at the lucky day activity, the probability, the expected number of trials that I would have to do is 1 divided by 1/7. And if I do that in my calculator, so 1 divided by 1/7, that would give me 7. So I expect to play the game 7 times, 7 trials, to get my first success. That's for the lucky game where we were guessing the day of the week. And then the standard deviation for that is going to be the square root of 1 minus 1/7. So the standard deviation of x is going to be the square root of 1 minus 1/7, all divided by 1/7. I would bang that into my calculator, the square root of 1 minus 1/7. Then I would divide that by 1/7, and that's going to be about 6.48, which means then my number of successes typically varies by 6.48 trials. Not the number of successes, the number of trials will typically vary by about 6.48 trials from the expected success trials of 7. So that's what that is all telling me. All right, so let's back it up and take a look at the problem they want us to do. A local fast food restaurant is running a draw 3, get it free lunch promotion. After each customer orders, a touchscreen display shows the message, press here to win a free lunch. A computer program then simulates one card being drawn from a standard deck. If the chosen card is a 3, the customer's order is free. Otherwise, the customer must pay the bill. Let X equal the number of customers it takes to get the first free order given in that day. So let's calculate and interpret the mean of X. So X is how many trials do I have to do to get X. So make sure that you tell me it is a geometric distribution, and then you identify the probability of success. So 1 out of 4 out of 52, which means 13. So if the restaurant runs this lunch promotion many days, the average number of customers it takes to get the first order, to get the first free order would be about 13. And this is how I found that mean. Alrighty, and then the standard deviation is 12.49. I do the formula, 1 minus p, all at square root, divided by p. So if the restaurant runs this lunch promotion on many days, the number of customers it takes to get the first order will typically vary, first free order will typically vary by about 12.5 from a mean of 13. Okay, so that brings us to the end of assignment 6.3. I broke down everything we have talked about. Remember our binomial coefficient, where I talked about that in another video, where I said n over x can be found in your calculator by doing the NCR, where the number of given trials and how many that we want to choose. And then they keep breaking it down. Alrighty, so let's go ahead and finish up that assignment. I will get the answers for 6.3 into Student View shortly, and you can get those taken care of.